Hello, good afternoon, everybody. I am doing very well, Luke. Thank you for asking. I'm a little tired today. Not sure if that's just because it was kind of cloudy earlier, but the sun is out. I actually have really good lighting today, and that's very exciting. Usually it's really kind of doom and gloom in the office at home. Yeah, I am very excited to have a little bit of extra time off this weekend. I'm heading out to Nelson too, so I'm very excited to check that out. I haven't been out to Nelson area before, so I'm very much looking forward to that. Yeah, for those of you that have been to Nelson, if there's anything that you recommend, feel free to let me know in the chat. I'm happy to take some recommendations. Definitely going to be planning some hikes. Yes, for sure. From what I've seen, it looks spectacular out there. Mountain biking, yeah, I never thought about that. I have a dog though, so I think the hiking is going to be the fair bet for exercise while I'm out there. I'm sure she'll appreciate getting out on some more hikes too. Just some housekeeping things as we wait for any other students to kind of roll in before 3 o'clock. We know that we just recently finished test number 1. So I have been marking my first batch of calculus assignments. So I just finished that late last night. So the next kind of set of marking for me to do is to go through your first tests. So I haven't had a chance to do that quite yet. What I typically do is I kind of open up the Dropbox, I open up the work that you've uploaded to the Dropbox, and then I go through each test one by one, looking at the answers that you've put into each of the 3 parts, comparing that with the answer that you have uploaded to the Dropbox, and then typically the marks do increase a little bit or a lot of it for many students, depending on what that rough work looks like. So I will send an announcement out once I have all of the tests marked. You'll probably also get a little notification from Moodle once I have looked at your Dropbox. So you'll start to get those hopefully over the weekend. As I kind of wake up in the morning in Nelson and start to enjoy my coffee, I will be marking your test number 1s. So I'm hoping to have them kind of ready and back to you by Tuesday next week. So that's the ditty on test number 1. It's still kind of work in progress. The other thing that is hopefully on your radar is the assignment number 2. So assignment number 2 is here, and you are ready to go on this one after today's class. So after we're going to finish up the kind of merchandising section today by doing a Monopoly kind of question. And that's really all the material you need for assignment number 2. For assignment number 2, you are permitted to do this in a group of up to 3 students. So you can do it by yourself. That's totally. You can work in a pair if you know somebody else in the class or are willing to reach out to somebody else in the class, or you can do it in a group of up to 3, no more than 3. Each group or individual will only need to submit 1 assignment. Just please make sure that on that assignment somewhere you have your names, because every student in the same group will get the same score. So it's important, if I don't have your name on anything, then I have to award you 0 if I have no way to connect you to the group that you're working with. So just be mindful of that. If you do want to reach out, so there is a little forum here called Find Group Members. So if you want to reach out, you're welcome to use that forum. Say, hey, my name is so-and-so. Does anybody else want to work on the assignment? That's fine. Of course, you can also private message people through Zoom during our class today if you want to reach out to somebody that you may or may not know and just want to ask them and see if they want to work together as well. Very manageable, I think, for this assignment on your own. But I understand it's kind of a busy week, a couple weeks for people as we start to kind of get into the midterm. This is kind of like midterm season, right? And I was about to say hunting season, because that's what my dad always says, but no, it's like midterm season, right? Like for many students. So yeah, if you want to kind of work together with people to lessen that load, that's fine. So Josh just asked me, I have a friend taking your class in a different section. Can I team up with her for assignment number 2? Hey, that's a cool idea. I don't see why not, Josh. So I mean, as long as, can you just, so you can work together. Can you just please make sure that I know which sections you're in? So just kind of like write your name at the top of the PDF, you know, section 5, her name at the top of the PDF, section 4, section 7, whatever section she's in, okay? And that way I can kind of match up the scores for you guys. But yeah, I think that's a cool idea. I'm totally fine with that. I mean, assignment 2 is the same for all 3 of my 114 classes, so that should be fine. So yeah, as soon as you know if you're going to work by yourself or work in a group, please go to the group choice here on Moodle as well. You're going to need to select one of these net prices in order to start the assignment. So if you think, you know, if you want to use 165, for example, click on that, save your choice, and I'll show you this is what we want to put into the first blank on assignment number 2. Okay, so if I open up assignment number 2, and you scroll to the second page, there's a little blank right here, right? It says, you know, I can get item A from a local wholesaler at a net price of blank. That's what you're going to fill into the blank there. As soon as you get your end value from your group choice, fill it into this blank, and then you should be able to complete the rest of the assignment based on that starting net price. And that's that. So there's 3 parts. It's all done pencil and paper this time, uploaded to the Dropbox. There is no video component for assignment number 2. And yeah, I've had students already submitting things to the Dropbox already. So congratulations if you are a little bit ahead of the game for the long weekend. Any other questions about test number 1 or assignment number 2 before we start working away at the material for today? Wonderful. So if you do have any questions, if you kind of like think of something along the way today, just let me know in the chat. You can either send it to everybody, or you can also just select me and send me a private message. That's totally fine as well. I'll answer those questions as they come up. So that assignment will be due by next week on Friday. So it's due October the 15th by midnight. So you can upload your PDF document anytime before next Friday at midnight for assignment number 2. And we do meet twice next week. So remember that if you do have classes on Monday, Monday is a holiday. I believe that's Thanksgiving for us here in Canada. So no classes Monday. Your college campuses will be closed, but we will meet during our normal times on Tuesday and Thursday. So if you do start working on the assignment over the weekend and you do have some questions, I will be available Tuesday and Thursday in that kind of like 2 to 3 o'clock timer, kind of like what I was today. All right, let's finish up the Monopoly section. I know it's, I feel like we haven't talked about a lot of stuff in a long time. We had like that, we had Truth and Reconciliation Day. We had the test day on Tuesday. So I feel like it's been a little while since we've actually had a good math class. I hope everybody's ready. I hope you have your math pants on. So the Monopoly section is typically a very small section. It might be 1 question on like this second assignment, or maybe 1 question on the final exam. And my preference, because I tend to believe that most of my business students haven't taken calculus yet. I tend to show the Monopoly section in a very specific way so that we can kind of work on it algebraically and from a more kind of algebraic and visual standpoint, rather than dealing with the calculus argument. So in the textbook, the hard copy of the textbook, it will probably go through the calculus approach to doing this, which talks about marginal revenue, marginal cost. For us, what we're going to do is just create the total profit function. We're going to factor that total profit function, try to observe where we have some break-even values, and then use symmetry of our parabola to essentially help us figure out where the maximal profit's going to happen. If you do want to quickly just jot down a couple of photos for yourself. I'm gonna open up the online version of the textbook here for you and show you just how it differs from some of the stuff we've been talking about before Truth and Reconciliation Day. So just give me a moment to find that for you. Okay, so there should be a link on our Moodle page to this particular chapter in the online version of the textbook. So it's here for you if you want to look at it, if you're curious about maybe some more examples or the calculus approach, it's here for you. But what I want to just kind of refresh your memory on is we've been working with total profit functions. And the total profit functions we've been working with have been linear total profit functions. So we had this formula, S minus C times X, subtract the fixed costs. That was the formula that we've been using. So S being the selling price, capital C being the cost price, X representing the number of items we're going to produce or sell, and then the fixed costs being subtracted from that total that we get. Now, the fixed costs, if we want to kind of visualize this on the XY plane, will represent our y-intercept. So if you're curious about, how does that translate to a picture of my total profit function, that's where it lands. So it lands over here in the fixed costs neighborhood. That's our y-intercept. We also did a little bit of a discussion last week on the break-even point of production. So this is setting the total profit function equal to 0 and trying to figure out how many X's, how many items we have to sell in order to kind of pay off our fixed costs. The break-even production can be thought of as the X-intercept. So this is what we've been kind of working with so far. We've been working with this linear kind of total profit function, and that may not necessarily be a truthful way to model total profit for a business. So this chapter kind of sets us up to look at a different way of thinking about our total profit in terms of a monopoly. So a monopoly meaning a business that really owns all of the shares in a given market. So in the online version of the textbook, I talk about companies like ICBC, that's an insurance company here in BC. They're the only insurance company. They have a monopoly. So they get to dictate essentially what the costs are for buying insurance premiums for their customers. So this is what we mean by monopoly. It's a business. It's really the only one of its kind, or maybe they have a specialized product that they have a patent on. And so sometimes the total profit function comes out looking a little bit different. It usually comes out looking like a quadratic style, or maybe even a higher power style of X. But we're going to deal with a quadratic style of X. And specifically, we're going to deal with a downwards facing parabola. And in this case, fixed costs can still be represented as our y-intercept. If we have a parabola that has a maximum, as we have in this picture here, there's two possibilities for break-even production, just based on the way that the nature of the monopoly is set up. So it's kind of saying, as I start to produce some items, I hit a break-even point, and as I start to produce more and more items, I eventually hit my maximal profit. But as I start to kind of increase production even more, notice that my total profit starts decreasing. And this could be because, we're selling the item at too high of a price, and now our consumers aren't buying that item. So it's kind of a loss to us to be unable to sell those things. So this is kind of what happens in a monopoly. That selling price has the ability to fluctuate a little bit, causing a more quadratic style of relationship here. And our goal is going to be to figure out, how many things should I produce and or sell to get this profit, to get this vertex point of the parabola. Notice here, there's really, really nice symmetry. So the key idea to dealing with a problem like this is, hey, if I can find the two break-even points of production, right smack in the middle of those break-even points is going to be the X value that I need to get the maximum profit. So that's going to be the way that we tackle this problem. And typically, I'm not going to be giving you like ridiculously hard things to factor. Usually, it's going to be something like a common factor. So take the time to Just copy down this question if you haven't done so already. And I'm just going to copy down our total profit function here and just notes to let you know kind of how we're going to tackle this problem. All right, so in red, that's our game plan. We're going to take our total profit function, try to common factor that, find the x values that give our intercepts or the break-even points, and then determine the next value that's right in the middle of those two break-even points. So once you're ready, let's go ahead and try to factor our total profit function. I'm going to do that just underneath the red here in black. So we're going to be going through term by term and trying to find what's common or what we can kind of take out that we think is common to both of these kind of things I've underlined in green. So it looks like if I look at both of these terms, the 50x and the 0.5x squared, it looks like both of them share an x. So I know I at least have to take that out. Now, typically, if I have a decimal number like 0.5, I know 0.5 divides really nicely into the number 50. So I'm going to actually factor out the 0.5 here as well. It's not necessary to do that, but I think it is going to be a little bit helpful for us in the long run. Okay, so I've taken out a number portion, I've taken out a letter portion. That's really all I can do with regards to common factoring. So now I'm going to go through each of those items I've underlined in green and divide. So I'm going to do 50 divided by 0.5 to see what I have left over. So 50 divided by 0.5 is 100. And then I do x divided by x. That's going to be 1. Next, I'll move into that next green box, 0.5x squared. Divide the number portion, 0.5 divided by 0.5 is 1. And then divide the x portions. X squared divided by x is a singular x. So here's what our common factoring is going to look like. And if you wanted just to write a little kind of note for yourself over on the side, this is kind of what I did. I took kind of my 50x and I divided by 0.5x, and that's where I got my 100. And then I took my 0.5x squared and divided by the common factor of 0.5x and said, well, there's just x left over after I do that division. So you can write that down if that's something that's going to be helpful for you to look back on in the future. All right, so our next goal is to sub TP equals to 0. Our total profit is 0. We're essentially going to now be solving for x, and we'll be finding those intercepts, or if you want to be a bit more, if you want to use kind of terminology that kind of fits in with this section, these are called the break-even points of production. So let's make our substitution TP equals to 0. And then try to figure out what x values are going to make this expression 0. Now, from my perspective, it looks like we have two options here. It could be that this factor is equal to 0. So it could be that 0.5x is 0. Or it could be that our second factor is 0. It could be that 100 take away x is 0. It's not 10, how about 0? So the idea here is I have two things that are multiplied together. This was the point of doing a common factor. And now I can look at each one of these things that are multiplied together one by one. Either the first thing is 0, either I have 0 times a number, or I have a number times 0. That's the only way that I can get 0 overall on doing this multiplication. So in our first scenario, if this first factor is 0, I can divide by 0.5, and I'm going to get x is equal to 0. In our second factor, I'm just going to add x to both sides, and that's going to show us that x is equal to 100. So I have two options here. If I sub in x equals 0, I get break even. If I sub in x equals 100, I get break even as well. So those are our two intercepts. Now that I have those two break-even points, I know that my maximal profit has to happen right in the middle of these 2 points. Easiest way to do that is to add them up and divide by 2. Wouldn't x equal 0.5? So what we're actually doing, if you want to see that extra step over here, Blake, I want to divide both sides by 0.5. By doing that, that's going to leave me with x. And then on the right-hand side, I'm going to get 0 divided by 0.5, and that's equal to 0. Yeah, no worries. It's kind of a weird one to see, but very similar to like our first assignment, right? So, when we had like 2 is equal to q is equal to 2p, and we sub in like q equals to 0, then p became 0. So it's kind of very similar to that kind of situation. Now, personally, I like to give one of the intercepts to be 0 just to make our lives a little bit easier here, because I'm not sure how comfortable everybody is factoring quadratic equations. But the idea here is if I did end up getting something that wasn't 0 when I factored, if I had two non-zero numbers, I could add them up and then I could divide by 2. That's going to give me the x value that I'm curious about. In our case, the middle obviously is at 50. Hopefully that's very intuitive for you, knowing that the two endpoints are 0 and 100. So we need to essentially have a production level of 50 units in order to hit our maximal profit level. In some instances, it's okay to stop here, knowing how many units we need to make. In some other instances, they might ask you a follow-up question, something like, okay, so now that you know that 50 units is going to give the most profit, what is that profit that I'm looking for? What's the maximal amount of money we're going to make by selling 50 units? Okay, so depending on the question, you might have this kind of follow-up. So once you find that x value, you can use that x value inside of that total profit function, which I can't remember what it looked like. 50x take away 0.5x squared. So 50x take away 0.5x squared. Yeah, so if I produce or sell 50 items, let's figure out how much profit we'll actually get. Okay, so subbing x equals 50. It's something like this. And then now we're in a good place to just put this into our calculator and see what's up. And doing that, I get a profit of $1,250. And there you go. And that's kind of how to tackle a monopoly question or something, a monopoly question that I would be willing to give to you. Common factor, find the two x values where we have break-even production, then find the middle point, and that's going to help you find that maximal profit level. Now, if you're curious about what this looks like, we could draw a little picture of this particular total profit function. And it's going to look something like this. I'll just plot it in red. So what we have is we have a break-even level of production over here at 0, 0. And we're also going to have a break-even level of production over here. This is going to be 100 and 0. Okay, so in other words, when x is 0 or when x is 100, we have a total profit of 0. That's what I know so far. There's also a point somewhere here in the middle, and I'm just going to plot it maybe up here. This is going to be our maximal profit. So we figured out that the maximal profit happens when x is equal to 50. And when x is 50, we found out that the total profit, or kind of the corresponding y value, should be 1,250. And then we know this is going to be a downwards facing kind of parabola, so we end up getting something that looks like this. Of course, if we wanted to, we could extend our parabola this way, but we probably wouldn't want to make more than 100 items if we know we're going to be doing that at a loss. And it doesn't really make sense to extend it this way because we can't make a negative number of items. So we're kind of stuck with starting at 0, 0 and getting this kind of like parabola that looks something like this. All right, so that kind of takes care of what I want to show you around Monopoly and how to solve a standard Monopoly kind of question. Let me know if you have any questions about that, or if you're ready to start something fresh. Let's get out of this algebraic stuff and let's do some easy stuff for a little while. I actually really like the second section of this class. It's I find the first kind of third of the class tends to be kind of like the medium hard part of the course. The section we're about to work our way into tends to be, I would argue that it's the easiest part of the course. So it's nice to take a little break, I think, kind of in the middle here when some of your other classes start to ramp up quite a bit. And then, of course, the third half of the course is kind of dependent on how good you feel about the second part of the course. So let me know when you are ready. Maybe just give me like a little thumbs up or a little yes in the chat if you're ready to kind of move into some topics on simple interest. That's what we want to talk about next. Okay, perfect. We got 4 or 5. I mean, we don't have to, but I mean, you're still going to be required to know some of this stuff, so we might as well do with some practice today. Okay, let's jump over into talking about simple interest then. Did you get a chance to watch the Days Between Dates video that I posted onto Moodle? That's the big question here. Okay, amazing. That's a lot of yeses. So we will work through a couple examples of this as we start to practice. But the Days Between Dates function on our calculator allows you to really prorate interest really specifically, like right down to the date almost. And this is helpful because if you've had a chance to look at the simple interest formula, you'll notice that the basic formula has a t variable, and that t variable is given in years. So if I don't have an investment or a loan that's happening for exactly over the span of 1 year, I need to be able to kind of prorate that a little bit. For example, if I want to just charge simple interest for a couple months, I need to know how to turn that into a yearly kind of number. And so this could happen too, where like maybe we go and invest something today and I want to pull it out, you know, maybe at Christmas time or something like that. And it's helpful to know how many days. This is quite often used for like insurance companies, right? If they want to prorate their insurance premiums for like a day for like a single use drive, or they want to prorate it for say 3 months. I think that's the smallest amount you can do in BC, right? As a kind of a 3-month term for your vehicle. So it's helpful to know how to be able to do some of this stuff. So our calculator has the capacity to do this, and I'm going to show you how to do this visually, but let's write down a couple notes first. So what we want to do, actually, you know what I can do? I actually can share my screen, I believe. So I'm going to open up my, just give me a second, open up the Business Math Calculator. And then that way I can at least show you kind of where some of this stuff is, and we can kind of write stuff at the same time. So let's see. Okay, so you guys should hopefully be able to see my notes as well as the business calculator now. I have no idea. I feel like someone, you're speaking like Spanish, and I'm not exactly sure how to respond. I know French. I know English and French. That's the 2 languages of Canada. Okay, so if you haven't had a chance to watch that video, the days between dates can be found by essentially going to the second button and then hitting the number 1. That gets you into the dates kind of sub menu. So we start by hitting second, and we go down and we hit the number 1. Okay, and that gets you into the date sub menu. You can use the arrow keys to kind of go through the sub menu. So let's write that down. So the idea is to do second, and then the number 1, which is the date submenu. And then we can use arrows to scroll. And then the other major thing we need to know is how the calculator wants your input and how to save that input. So this is the word arrows, sorry. The input, or the kind of the format that the calculator wants, is month first, right? It goes month, month, I believe, month, dot, day, year, year. So it needs 2 numbers representing the month, 2 numbers representing the day, 2 numbers representing the year. And once we've put that into one of our dates, we can use the enter button to save. And the CPT, or the compute button, which is in the top left corner. Okay, so the CPT and the enter button are beside each other up here in the top left. The CPT button we can use to kind of find the thing that we want, which is usually DBD, or the days between dates. You can see that on my calculator here. So that's usually the number that we want, and then we use the compute button to get at that number. And let's just say computes DBD. It can be used to compute a date as well. So So if you know the number of days between dates and you know one of the dates, you can actually compute one of the missing dates if you want, which is kind of fun. But let's take a moment maybe just to maybe practice, and let's figure out how many days old you are. So let's see if we can use the DDD function to figure out how many days old we are. And then it's up to you. You can share it in the chat. You can PM me if you want, or DM me. I will share some of those numbers. We can figure out who's the youngest, who's the oldest. I always find this kind of like a fun little exercise. So grab your calculator, hit the second key and the number 1 to get into the dates submenu. Now, if we want to figure out, I'm oldest with no number, so you already know, you've already accepted the fact that you are the oldest. That's so funny. So if I want to program in, let's go to DT2. So what I'm going to do, like what we need to do is we need to program in our birthday as DT1, and then we need to program in today's date as DT2. So what's today's date? October 7th. So we're going to program that in by going 10, decimal, 0, 7, and then we need 2 numbers representing the year. So 2, 1 should work. So that is October 7th, 2021. Hitting the Enter key will save that. And you can see kind of that format change. So see how it changed to 10-7-2021. I do recommend making sure that the year comes out properly when you're using the DBD calculator. We ran into an instance where 1960, for example, didn't come up. So they wanted a date in 1960, but it came up as 2060. So the calculator has kind of a predetermined range of what years it thinks you're working with. So apparently 1960 is outside of that range. So yeah, be mindful of that. Just kind of note, just make note here when you're saving these dates that you want to double check that year especially. Okay, I'm going to go back down to DT1. Hey, someone PM'd me and said 10,929 days they've been living. That's kind of fun. That means I think we're going to be kind of in a very similar boat. My personal birthday is what I need to put in as DT1. So I will go ahead and do that. I'm a summer baby. Okay, so my birthday's in as DT1. Today's date is in as DT2. And if I go to DBD right now, it says 64, but I haven't computed anything yet. I need to actually hit the compute button in order to calculate the number of days that I've been alive. Nice. Hey, I got some friends. We're in a very similar age bracket. Hey, I have someone who said 8,301. I'm sure we have somebody that has fewer days alive than that. Yeah, so someone just messaged me and said 6,827. So yeah, I'm expecting that the youngest of you are going to be somewhere in that 6,000 days range, right? So I'm typically about twice as old as most students in this class. 6,900 even, that's fun. 7,140, very nice, very nice. I love the message that I got from somebody saying that, yes, I couldn't get my date into the calculator. Oh no. How do we check that it's correct? Mine seems wrong. Did it give you like something like really small or really got an error 6? Oh, interesting. So if you got an error 6, that might mean that your days are mixed up or that you inputted the format incorrectly, right? So date 1 has to be further back in time than date 2. So make sure that works. Error 6 might also pop up if you mix up the month and the day, right? So for example, this calculator will understand 7.10 if I enter that, but it may not understand if I try to put 22 first, right? If I try to put 22.08, I think it might get mad at me if I try to do something like this. So error 6 probably means that you have the month and the day mixed up. That's my guess. Oh, so you will need a decimal between the 10 and the 7. So compute, there's a CPT button up here, Steph, in the top left. So once you're happy with your two dates, you come to the DBD screen and hit the CPT button. So my guess is you maybe just missed the decimal place to get that error 6. Okay, so we do need a decimal in between the 10 and the 7. Okay, and it looks good on mine. So it might be something like that. Hey, no worries. Once you get used to it, it's kind of second nature, but yeah, it usually takes a couple errors before you kind of iron out the kinks. But that's the idea with the days between dates function. We have about 10-ish more minutes, so I'd like to put us into a couple situations where we talk about simple interest, and then we can pop up the days between dates if we need it. So let's at least do a couple examples with our basic simple interest formula. What we will do next week on Tuesday is come back, we'll look at the future value formula, we'll look at the principal amount formula, and start to think about time diagrams and working with some kind of bigger and more challenging examples as well. But for now, I just want to kind of introduce you to the basic formula for simple interest. Oh no, negative 16,000. Yeah, that's a bit weird. I wonder if your DT1 and DT2 are backwards. You'd have to message me what you have as input, right? So if you're getting some errors and you're like, I kind of want to clarify what the errors are, you just let me know kind of what your inputs are, right? So my inputs would be 8.2284 for the first one. And then for the second one, I would use today's date, which is 10.0721. So if you ever want to kind of figure out what's going on, you're going to have to give me that information because I can't see how you're typing this in. Right, and remember, error 6 means you're missing the decimal, you've swapped some numbers or something like that. And yeah, if you have an older birth year, then yes, it's quite possible that the calculator may not be able to calculate the days between dates for you if your birth year is too far in the past. Hey, we got a 10,029. Not bad, not bad. So here's our basic simple interest formula. It's I is equal to P times R times T. Yeah, that could totally be the reason as to why it's not working. I think someone else ran into that situation in my other class. They were born in the 60s, so the calculator was unable to figure out that you wanted 1960, and it kind of assumed that you wanted 2060. So yeah, that could break the calculator by accident. So I apologize in advance for those of us that might be a little older than the youngins. So here's our basic simple interest formula. I is equal to P times R times T. Capital I here represents the interest that we make in dollars. So the scenarios we're going to be talking about are we are going to maybe be taking some money called the principal amount, investing that somewhere, and over time, at a particular rate, we're going to make money on that investment. This is called the interest. A rate typically has to be given, and when the textbooks that we're working with deal with a simple interest rate, which is a yearly kind of rate. So that means when I'm talking about prorating, when I'm talking about this time variable, it has to be in years as well. Capital P here represents what we call the principal amount. This is the starting amount that I either invest or the starting amount that maybe I've borrowed from somebody, like in a loan kind of scenario. So both of those are reasonable ways to think about capital P. It just depends if you're investing or if you're taking out a loan. Sometimes the time or the length of the investment is also called the term. So just be mindful of that too. So if you hear the word term, this is telling us we want to talk about T, the T variable. So this is our kind of basic formula to calculate how much money I think I'm going to earn in a simple interest kind of scenario. So I'm going to open up the chat for you while I'm just kind of going to keep write up some examples for us. I don't know, does the textbook discuss the difference between simple interest and compound interest right away? Or maybe do one of you happen to know the difference between simple interest and compound interest? Those are the two main types of interest that we want to talk about this year. Yeah, that's nice. So yeah, typically simple interest is on like for short-term loans. Absolutely. I think that's a great way to think about simple versus compound. So simple interest is typically a shorter term loan. Yes, and it's true, compound interest typically is going to be a longer term loan, although that doesn't necessarily have to be true in our kind of fake situations that were put in this year. There's one other really big factor between compound interest and simple interest as well. And that is that simple interest, we only ever earn money on the initial or the principal starting amount. In compound interest, we're going to see that every time we earn interest, that money goes kind of back into a new pot. And then that new pot is allowed to earn interest in the next time period. So that's another big difference that we'll talk about once we get to the compound interest section. So for now, what we really can do is we can think about simple interest as just like a tax, right? So I'm investing some stuff. There's a rate that I'm earning money at, and then it just happens one time, which is really simple. Dad joke. Okay. So let's set up a situation where we have to kind of work with this formula, maybe use the DVD function before we sign off for today. So let's say we invest 5,400. We're going to put that into an account that can earn 5.75% simple interest. So if you ever see me write SI, that means simple interest, just a short form. Let's figure out how much interest, or how much interest in dollars will be made. And then let's do a couple different scenarios. So scenario one, let's do over 1 year. Two, let's do over 2 years. Let's do over 5 months. And let's do between the days between October 31st, 2021 and Christmas. I think it's just kind of a nice example, a nice warm-up example for us, just to kind of get us used to how simple interest is calculated, and a little bit more practice with the DVD function. Should be able to tackle these fairly quickly. I know that maybe some of you have some places to go, so give me like 5 to 7 minutes here and we'll finish this on up. In this particular example, we do want to use I equals PRT for all of these calculations. The only thing that's really going to be changing in this example is how we deal with T. So T has to be put in years. All of these examples have a principal amount of $5,400. And all of them are at the same simple interest rate of 5.75. So just be mindful that our rate is going to be going in as 0.575. Sounds kind of a bit of an annoyance to put in, but c'est la vie, Now, over the span of 1 year, what does that mean I should sub in for T? Well, I guess if T is in years, and we're going to be doing this over the span of 1 year, it kind of makes sense to put T is equal to 1 in this particular case. Yeah, exactly. Okay, so let's multiply this out and see what we get. Yeah, I get $310.50. So this means over the span of 1 year at this particular simple interest rate, that's actually pretty high. That feels high. I'm going to do that one more time just to make sure I didn't mess it up. No, that's the answer I get. So this is how much interest my principal amount earns over the span of 1 year. The nice thing about simple interest is I find it quite intuitive. So if I know how much I make over 1 year, how much do you think we make over 2 years? I think we can probably just double that. If every year I'm making $310.50, over the span of 2 years, my guess is we're going to make $621. Yeah, that's what I think. Let's show that using our formula. Now, instead of multiplying by 1 at the end, we're going to multiply by 2 since we're over the span of 2 years. Okay, putting that into your calculator, hopefully you can convince yourself you do get $621. So that's kind of a nice, I think, property for this particular interest to have, right? If I know what's going on in the span of 1 year, I can kind of make it make sense for 2 years, make it make sense for 3 years. Now, what do you think is going to happen for something like 5 months? How do I deal with a monthly kind of simple interest? Yeah, nice suggestions, guys. So the idea here is if I know what's happening over the span of a year, I can divide that into 12 months, and then I want to take 5 of those months. So it seems very natural to use 5 over 12 as a fraction in here for t. Okay, so the idea is I'm going to be dividing into 12 equal portions to represent that this is going to be a monthly prorating. And then the numerator tells me I want 5 of those equal-sized pieces for my 5 months. So that's the idea here for number 3. And because there's no addition or subtraction in here, we can actually just go right to our calculator and just tell our calculator to essentially multiply these things. So I would go 5,400 times 0.0575. I'm going to multiply by 5 because that's the number in the numerator, and then finally divide by 12. Okay, so an answer for number 3 is I get $129, and I do have to round that to 38 cents. So I have to round that one up a little bit. All right, so I'm going to zoom out just so you can see. Our last question here. So for our last question, we want to figure out what's going on between October 31st and December 25th. So usually when I encounter a question like this where I know I have to calculate the number of days, I'm going to write down something like this for my rough work. And I suggest you guys do that too on like an assignment or a test. That way, if something comes out funky on the other side, I at least know that you know how to program it into the calculator and can give you partial marks. So in this case, I know we're a little bit past time here, but I'll do this quickly for you. So October 31st, 2021, we have December, which is the 12th month, 25th day, 2021 as well. So I'm just going to write down how I put that into the calculator like this. Make sure that I'm still sharing the screen for you guys. Perfect. So DT1 gets programmed in as 10.3121. I'm going to go up and hit the enter key to program that in. Scrolling down, let's program in our December, so 12.25, 2021. Hit the enter key to save that. And then scrolling down one more time, I have to hit the CPT button in order to find out that there are 55 days in between Halloween and Christmas this year. 55 days. Geez, and we're almost to Halloween already. Man, we're almost done this semester. We're almost at Christmas. Isn't that nuts? Geez. Okay, so if you're happy with 55 days, the last step is to figure out how to convert that into something I can input for t. So if I know it's 55 days, what do I do for the time variable over here on the right side? Yeah, so it's just a matter of saying, okay, well, I know there's 365 days in a year. So that's going to be our denominator, and we're going to put our 55 in the numerator. Yeah, so as soon as you know the days, it's going to be a fraction over 365. Let's go ahead and quickly calculate that one and call it a day. Here I get around $46.79. Yeah, perfect. Okay, nice. Awesome. So that's kind of a nice little, I think, gentle introduction into simple interest today. Hopefully you guys have a really lovely holiday weekend. I know you've probably earned a little bit of time off and hopefully you don't have too much to do. I'll see all of you on Tuesday. We'll continue talking about simple interest, and our main goal on Tuesday will be to look at the future value formula and the principal amount formula and use that to do some calculations, okay? Thank you, Emily. Nosh, thanks so much. Yeah, hopefully you have a great weekend as well.
Have a great long weekend. Thanks, Prof.
No, thank you so much.
Thanks, Professor. Good weekend to you.
Yeah, very welcome. Have a good weekend yourself. Oh, Elaine, did you need to get your calculator set up correctly?